This is just who I am. I forget stuff. All right. So the stem plot is not really a technological. Actually, the last two are not really tech-based. So it really isn't so much a matter of you being able to navigate through a device like Desmos or, Microsoft Excel or anything like that. It's more so just having a general understanding of what the technique of the display is, right? The good thing is it's really not that difficult. It does require, so I'm just kind of putting myself in your shoes. You're prepping for a test. You just got to remember, when it comes to graphs, you just got to remember the little fine details like labels. That's the thing that always gets me. I try not to be too nitpicky about little things, little details. But so with that being said, when I am nitpicky about something, it's because it's a really important idea, right? And when you're dealing with statistical graphs, if you don't have a label, it's like you don't even have a graph, because yeah, you got bars and you got stuff drawn and like it might look glorious like this beauty right here, but if it doesn't have labels, there's no context to it. Nobody knows what the hell you're talking about. So, it's almost like you sort of walk in on two people having a conversation midstream. You don't have any basis to understand what the conversation is all about, but you chime in anyway. People do that all the time, but it's out of here. Sorry. Yeah, the idea is that you want to be able to have a quick way of referencing or understanding what the data or the graph is referencing, right? So a stem and leaf display is a quick way of doing that, but only for small data sets. And I would even preface everything in this unit by saying that all of this stuff only really works for small data sets, because once you start getting involved in large data sets, you're starting to look at technology like Excel or Desmos or something like that. Right? So what's a stem and leaf display? Well, the first thing is you can think of any number as being partitioned or split up into two different groups. One group would be a stem, the stem group, and the other group would be the group of leaves, right? When you're dealing with a two-digit number, it's very easy to identify the stem versus the leaf because there's only one way in which you can partition a two-digit number, right down the middle, right? If I'm going to split that number, there's only one way that I can do it. Now, a three-digit number, I got two possibilities. A three-digit number, I could split it here, or I can split it here. All right, so we'll have to cross that bridge in a minute. But for a two-digit number, right down the middle is my only option. And for a stem and leaf display, I do need to be able to split the number. Now, if you have something like a collection of five-digit numbers, and like let's say you have 20 of those, you have a lot of different choices of where you want to split those values. There's no wrong answer. It's what you do after you make the decision of where you're going to split those values that will define whether or not you get full credit, as in you created the graph appropriately. But the value on the left is your stem, the value on the right is the leaf. All right, so that's going to be consistent for all of these two-digit numbers. So that part is super easy, barely an inconvenience. I heard that somewhere. Ryan George, you too. Oh, I like copying and pasting. It makes my life grow. Now, in reality, I don't think I need to label them all, but I'm gonna. So just bear with. this is one of those aspects of an app where you're like, okay, yeah, it's cool that you can do that. I've already labeled all this stuff up and I just got a pencil. So how good is your app really? Yeah, I know. I mean, it's not the greatest, but it is what it is. So that the 100, the 0, I'm going to erase this because I don't need that there. Actually, yeah, I'm going to erase that because I don't need it. The 100 and 0 and all that stuff, they're going to fall in separate categories. So I got to tackle those separately. But the 2-digit numbers, those are officially tackled. We've accounted for those. All right. So now it's just a matter of figuring out what's going on with the other ones. All right. Good news is we do have an idea of the little convention that's being used in order to establish the relationship. So just going back to that first value. Yeah, it's stem and leaf, but this is the ones place and this is the tens place. I always kind of enjoy the moments where my classes sort of line up. You know, the content that I'm teaching in one class lines up with the material that I'm teaching in another class. So like I just mentioned the ones place and the tens place. And last night in my math for elementary school teachers, I just went over how to teach the difference between the ones place and the tens place. So it's kind of like interesting in that regard. But when I get this, when I think of it that way, I can start to realize, okay, so yeah, I split it down the middle. That's one way to think about it. But what did I really do? I split it between the ones place and the tens place. All right. So that's what I'm going to do with the 3-digit numbers, the ones place and the tens place. All right. So that's going to actually give me a 2-digit stem and a 1-digit leaf. All right. So we're just going for consistency, but you know, that's a good way to come up with the that relationship. Another way to think about it would be like, okay, my stems, I got 1, 2, 3. Well, I don't have a 3, but 4, 5. I got a 7. I got an 8. I got a 9. What comes after 9? 10. So that probably means that the 100s, which come after 90, would most likely have a stem of 10. Right? Now, as far as the 0 is concerned, 0 is an interesting case because 0, 0, 0, 0, 0.0, 0, 0, 0.0, they're all equal to 0. So I could put as many zeros before or after a 0 as I want, and it's still going to have the same value. So I can make a 1-digit 0 into a 2-digit 0, and I'm just indicating that I have 0 in the tens place and 0 in the ones place. Still equal to 0. Mission accomplished. I now know how to partition it. It's a stem of 0 and a leaf of 0. All right, and that's all wonderful stuff. Now I got to make a graph out of this. Now you might look at this and say, I thought you said this was going to be quick. Well, the explanation part takes a couple minutes, but actually carrying it out when you start getting a handle on it, you'll see that it's a lot quicker. All right. So I'm going to identify my smallest stem, which is 0, and my largest stem, which is 10. I'm going to make a list of stems going from the smallest to the largest. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you go off the chart there, that's fine. Not losing any sleep over that. What we're going to do is indicate the corresponding leaves associated with those stems. So I'm going to work across my table, top row, then the bottom row. And all I'm going to do is in each row corresponding to a stem, I'm going to write down whatever that leaf is. All right, so we'll start off with the first one. All right, so we're starting off with 80. 80 has a stem of 0 and a leaf, a stem of 8 and a leaf of 0. So I'm going to put a 0 in the leaf column for the row 8. All right. Then I'm going to take, so I'm working across, looking at 91. I'm going to put a 1 in the row associated with the stem of 9. Then the next value, we have a 90. So I get another value that's going to go into the 9 row. That's fine. I just need to create a little bit of spacing. So we don't use commas, no semicolons, no punctuation or anything like that, because this is a graphical display. It's just kind of weird to think of it that way. What I'm going to do is I'm going to put that next stem of 0. I'm just going to put it adjacent to the 1. Just give it a little space. All right? A little extra tail there. Doesn't matter. All right? Well, it did matter, otherwise it wouldn't have changed it. 51. A 1 lined up with all the first digits in the leaf column, right? So all of these values are lined up, right? As best you can. They don't have to be perfect. You don't have to put a ruler on it or anything, but it should be relatively following the same column, right? 75. So that's a leaf of 5 in the stem row of 7. Now you see here we have 2 83s. So I'm going to put 2 3s in the 8 row. So a 3 here, and then I'm going to, using consistent spacing. So, I got like a 1/4 inch spacing there, and whatever. I'm going to do the same distance over to the right. Just eyeball it. The width of the pinky. That's all you need. Just some sort of consistent spacing. That's all we're looking for. Looks like I got another 80. The question that often comes up is, wait, the 80, I already got the 80. Do I need to put it again? Well, if I tell you that the context here is that these were a class set of test scores, it kind of matters if 2 people got an 80 as opposed to 1 person. 2 people got a 100. 2 people got 95s. That's all important information. All right. If it turned out that like 1 person got an 11, but 30 people got 100s, then that's telling me it's a pretty safe assumption that it's a solid outcome on the class. All right, I got some questions. We got a couple of 95s. Boom, boom. So 5 and another 5 in the 9 row. Then we get to the 10 stem with a leaf of 0. A 0 leaf associated with a 0 stem. We got another 100, so 10 with a leaf of 0, so these 3 values are now accounted for. We just chuck that down there. A couple of 75s, so that's these 2. Get them right in. 56, 42, 25, stem of 2, 5, leaf of 5, stem of 1, leaf of 1, stem of 5, leaf of 5. All right, now you look at this, and if I don't know, I often say if you think anyway along the lines of the way I think, then you're looking at this saying, what the hell? But you don't even have to think like I think in order to say what the hell in this situation. It's like, all right, okay, cool. Let me show you what the benefit of a graph like this is, all right? And if you remember last class, we created frequency histograms, and they weren't crazy. When you came up with a frequency table, there was a little doing there, but once you came up with the frequency table, it wasn't overly challenging to come up with a graph. It just took a little time and patience. So what I'm going to do here is I'm just going to do a little screenshot. I'm going to manipulate it a little bit, bring it in, clean it up, maybe bring it on down. Just overall making a nice looking graph. I'm going to pop it on in. And I cropped it. Why is this here like this? I don't like the looks of that. All right, I guess I'm cropping it again. Whatever.
In this, if we had a figure of, say, 1,000, we would just keep the leaf as the single digit, and then we'd have a stem of 100 if it were like the number 1,001.
Yeah, exactly.
Cool. Thanks.
So I'm turning this on its side just to give you a little bit of a sense of what's going on here. If I were to bring this in a little bit and create little bars, around all of these values, you know, poor quality bars, of course. I don't want to increase the standards too much on my artistry, but I would have one value here, one value here, one value here, one value here, three values here, 3, 4, 4, and then back to 2. All right. Hopefully that's looking a little bit like a frequency histogram. Right. I mean, at least in terms of the quality of the drawing, maybe not so much, but in terms of just like the overall theme of it, right? The values that correspond with 0 are in the 0 to 9 interval. The ones are 10 to 19. All the numbers from 10 to 19 would have a stem of 1, 20 to 29, stem of 2, 30 to 39, stem of 3. So this is basically a shorthand way of coming up with a frequency histogram. So what a lot of people do, instead of just doing what I did with manipulating the graph, is they make the stem and leaf display, and then they just turn their head and say, oh, so that's what the histogram would look like. Now I didn't have to create the histogram. All right. The only thing is there's a little trade-off, and that is making the determination of where your stem and leaves are going to be. Like, is it going to be a 1s and 10s place split, or is it going to be something else? So that could be a little quirky. If I gave you a set of 3-digit numbers, half the class is going to split it after the between the first 2 digits, and the other half of the class is going to split it between the last 2 digits, and that's fine. I just got to make 2 separate answer keys so I can give everybody full credit. You know, the only little twist that people run into trouble with here is they lose credit because they don't include this really important characteristic, and that is a little key indicating what your stem and leaf display represents. Because if you think about any time you've ever seen a graph in a newspaper article, if newspapers exist, you know, online paper, you know, digital journal, textbook or something like that, you don't see the data, you just see the graph, right? And that graph always has a key or a legend. Sometimes they call it a legend. That's a way to interpret the graph so that they don't have to give you page after page after page after page of all the raw data. All right, so you give just a quick example of what this data represents, and that's enough for the reader to say, okay, now I know what everything means. So a way to decode it. So for example, I might say 5/1 means 51. Right? So you're just given one example from the graph in order to understand what that graph represents, and then that's your full credit response. Right? So you think about it from the perspective of making a quality graph that people can understand and interpret correctly, but then you're also thinking about, I want to get full credit on a test. So there's that part of it too. All right. So just make sure you have that key in there. It's very, very important. It's so important that I can honestly say, for the folks who, you know, like when you sit down to take the test, there are some people that just, you know, like they don't attend class, and when they're here, they don't pay attention, whatever, you know, so they wouldn't know what a stem and leaf display is to begin with. I'm not talking about those folks. The people who have studied and prepared and earnestly tried to do well in the class, the only thing they ever screw up, if they screw up anything at all, is the key. That's the only thing they ever forget. I try to be very gentle about it, but I still got to take off some credit. I take off half a point, right? So it's usually a 5-point, 4-point, 5-point question. I'll take off half a point, not half credit, but half of a point. So it's a little bit of a ding, but I do have to do it because it's an important part of creating a graph. So this is the thing that I'm nitpicky about, but I think it's the kind of thing that everybody would be nitpicky about. So make sure you have that key in there. It can be any example, right? That's usually the next question that comes in. All right, was there a question there?
It's a pandemic. Give us all an A. Don't take points off.
Yeah, I can't quite hear.
She said, it's a pandemic. Give us all an A. Don't take any points off.
You have to add points.
Oh, I didn't know. I didn't know. I didn't know.
It's a
Oh, wait. So then wait, I don't even have to be here. They're just going to pay me? That's how it works? I had no idea. Sounds great.
Professor, so where should we be displaying the key?
Oh, this is the explanation of the key.
Yeah, I know, but it should be like that on the paper?
Yeah, something like that. Yeah, I mean, you could choose any example that you want. But I mean, if you want to do 1/1 = 11, that's fine. That is the explanation. The reader will know that that's what the translation of the graph is.
Does it has to be for each stem and leaf?
No, just one example.
Okay, perfect.
The key, the question was, what does the key even mean? The key is a way of interpreting the graph, because what I was saying before is when you're given a graph, like in the real world, like in a presentation, they don't give you the data set along with it. They just give you the graph. So if I told you, here is some information related to how students perform typically in my class, and then I didn't give you, just get my pen. I didn't give you any of this information. All I gave you was this. I didn't even give you that. I just showed you that graph and I said, here's how my classes normally do. Here's an example. Anybody in their right mind would look at that and say, what was that supposed to tell me, right? But if I give you this, then you could say, okay, so the 5 in the stem column corresponding with a 1 in the leaf column means 51. I mean, there is some requirement that you know what a stem and leaf display is if you're interpreting a stem and leaf display. So there's that part of it. But if you know that the stem is 5 and the 1 is leaf, and that means 51 and not, for example, 5.1 or 5 to the first power or something like that, then you now know, okay, I got a 0, I got an 11, I got a 25, a 42, blah, 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 blah. Okay, so a lot of people did really well. Handful of people didn't do so well. Got a 0 in there, probably cut class. I got 11 in there. That person probably wasn't really doing much of anything. So that's that, you know. But you now have the means to interpret it, whereas before you wouldn't have. All right. So that's really all that comes down to. So I guess some questions coming in. Oh, okay. So it looks like I just answered that. All right, good. All right. So the dot plot. The dot plot is an even simpler way of displaying data, but it could also be kind of a more painstaking and tedious way of doing it. So simple conceptually, but it can be kind of like, I don't really like this one because I gotta like write stuff. So let me steal my data set again. I just need to copy. I need to be able to refer to it, so I don't want to have all these markings on it. Let me just move this stuff out of the way for a sec. Good enough. And then let me move this. Oh, hello. Let me move this stuff back. Making sure it's marked. Okay. All right, so we're looking at this information here. I'll get to the chat in a second. I'm just going to swing this down a little bit. So a dot plot is, I mean, the simple way of explaining it is to say it's a plot that has dots in it. So that part's easy enough. But what we do is we create a number line going from the lowest value to the highest. So it starts off kind of like a box plot, the lowest to highest value, break it up into even increments. So here's my 0, here's my 100. I'll throw in a 50, a 25, and I broke it up by 5s. The idea is to have a consistent scale. Nothing wrong with a freehand approach, right? So as long as you have a reasonable amount of spacing, you're going to be perfectly okay. I'm not looking to, and again, if I'm looking for precision, like 100%, like precise accuracy, then we're looking for technology anyway. We're not looking for a by hand construction, all right? So all you're going to do is kind of like a stem plot. You're just going to work your way through the data set, but instead of stems and leaves, what you're going to do is you're going to plot points a certain distance, whatever distance you decide you want to be consistent on, just like a stem plot, above whatever the particular value is, right? So we're starting off with, so we'll do it the same way in terms of going through it. We're starting off with an 80, right? So above the 80, some predetermined distance, I'm going to plot a point. Then the 91. Now 91, I have to ballpark, right? So 91, I'm going to say it's about right there. And just to make it a little bit more clear, I'm just going to chuck the little 91 at the bottom, because I don't want to have to label every single number between 0 and 100, just to account for the ones that aren't multiples of 5. So I'll ballpark the one that is not, and I'll just kind of make a little note of what it is. So I'm just going to keep the height relatively consistent. The next one up is a 90. So I plot a point at above the 90. All right, I don't need to label that because that's one of the multiples of 5. All right. Next one is 51. That's not a multiple of 5, so I'm gonna put a little 51 down here. Again, just estimating. I can grab all the ones that are the same. Like I got a couple of 95s. I can do those at the same time if I want to be a little bit more efficient about it. So I can look at this and say, okay, well, oh, the 75s, I got 3 of those. So let me do that. I'll highlight it in blue. 1, 2, 3. So I would want 3 dots above the 75. So I would start off with the 1 to establish the spacing, and then I want consistent spacing. All right. So then I got the 95s. So I got 2 of those 95s. I can plot 2 points above the 95s. All right. So then we have, and you could just go through it in any way that makes sense. You know, like I'm going to just keep going. I got a couple of 83s. So where are my 83s? Well, they're just a shade north of 85, a shade south of 85. So here's 80, here's 85. So I want to be just a little bit less, right? And I have 2 of those 83s, so keep the consistent spacing and just make a little note at the bottom that here's my 83. All right, then I have my 80. All right, I already had 180, so I just got to pop in the second 80. All right, so that's taken care of. I got a couple 100s. I got a 0. I don't like having a 0, but I got it. There's no way around that. I'm going to face the facts. I get a 56. So here's 55, so 56, I would say is about right there. The spacing got a little wonky there, but that is what it is. So, you know, that's okay. I'm allowing for that. Same thing with around the 42. I'll call it right here, and I'll just make a label at the bottom, 42. 25. 11. Making a little note. And then 55. And so what we get from this is a nice display of the distribution of data, and you can see that it's mostly skewed. We'll talk about skewness in a little bit, but if we're talking about it tailing off, most of the data being in one group and it tailing off in another group, then this is definitely filling that definition. So that's what a dot plot is. You can see it's painstaking, it's kind of a pain, but it requires the least amount of thinking. It's more mindless, but it gets the job done. All right, so let me stop the recording. Let me take a